Luka, you're going to start off speaking, and you're going to share some of your experiences from the bank side. Marko is actually an Ethereum freelance Ethereum developer. And then at the end, you have a 5-minute demonstration of something. And we have time for Q&A.
Yes,
okay.
Thank you.
Thank you.
Hello, developers. How are you? Are you tired a little? It's Thursday. Okay. My name is Luka, and I'm working in ICT department in Banka Intesa in Belgrade, in Serbia. And in past, I work on a lot of projects. Some interesting projects are about cryptography, where we need to implement the software and hardware cryptography, use some modifications on authentication methods, improve some systems by security, and it's very interesting. Please, Marko, tell us more.
I'm a software Marko from Belgrade, a software developer for a decade. I have started as an embedded developer, then switched to system software development, Android, web applications. I like to change things, so to say. A year ago, I have refocused my career around cryptocurrency and the blockchain development. So for some time, I was a freelance Ethereum developer. And recently, I have joined the SafeX project as a core blockchain developer. So we were already on a couple of blockchain talks, and we have learned that here there are very few developers in the audience, but many people are very interested in blockchain. So today we would like to cover one very important topic, and that's security, blockchain security and smart contract security. So it's a crucial aspect of the blockchain development, probably much more important than security is in the other fields. So Luka will start with, let's say, more low-level crypto story. And I will follow up later with the smart contract development and security issues. So, Luka?
Thank you, Marko. Why blockchain? Today, blockchain is a part of many projects, of many solutions in many industries, like plane industry, automotive industry, bank, insurance, health, and many, many others. Many people think about blockchain, think to use, think to involve in this world. Here you can see market cap of cryptocurrencies currently, peak of some great cryptocurrencies, the famous cryptocurrencies like Bitcoin, Ethereum, Ripple, and other, and of all cryptocurrencies market. You can see that this information, this values are comparative with the market cap of great companies, bank companies, IT companies, and because of that, many people are interested in blockchain and cryptocurrency. Investors, IT enthusiasts, developers, many people from governance, from bank, and of course, hackers. Hackers try to steal your money, to steal some coins, and they try to steal money from companies, from exchange office, and they try to find some bugs in algorithms, in code. And because of that, we try to tell more about that, how to code secure and how to make good, how to make some positive things in your project and protect from the hackers. And blockchain is based on cryptography. Two types of cryptography are elementary for blockchain. One is one-way functions, known as hash functions. And second is asymmetric cryptography, private and public keys. Asymmetric cryptography we use to make a digital address, to store our money, to make account, and to know how many money we have, to know our balance. And second type, hash functions, we use to make a chain of blocks, blockchain. We have some information about transactions. We need to sign this information with the hash value, and then this hash value from block 99 use in block 100, and use some new information about the transactions, and then make a hash, and so on. On that way, we have integrity of data. No one can change this information, but it's okay, it can happen. Someone can change this information, but we know. We can know when we make a new hash that information in some block are changed, and thus we reject this block. Okay, because it's not usual when we create some application to use security for functionality. Here in blockchain, we use two types of cryptography to make a functional application. And do you know how work one-way function, hash function? I believe that you know. It's based on complexity math, and when we have something, data in input, like plain text, and when we put it through hash function, we have output, hash value, digital signature, and in this process, we lose some data. If we want to go back, we can't. Okay, in some simple example, I can show you how much is square root of 4. Can we know exactly how much is it? It's plus or minus 2. We don't know exactly. It's the same with the hash function. Okay, in blockchain world, we have many threats. And hackers have stolen about $1.7 billion in the last 7 years. 40% of this sum was stolen this year. It's some of these activities based on problems in smart contract, based with the implementation of passwords of cryptography, and because of that, we need to think more about security when we develop some solution on blockchain. Here you can see great number of hacker activities from 2011 to 2018. I think that this line go up exponential when we talk about hacker activities. We have some crypto challenges when we develop a new solution. We need to think about strong algorithms. Okay, we know now that one-way functions, the best one-way functions are SHA-2 and SHA-3. Okay, but in the past, sometimes we use MD5 and SHA-1. Do you think that how to improve your solution, how to improve your application when this algorithm will be broken? Do you think sometimes, maybe, I believe that someone developed some website authentication feature with the MD5 and SHA-1. And sometimes I do IT audit, security audit of application design, of security design, and I saw many applications which still use MD5 or SHA-1. I asked them, how you improve this problem? Many people don't know. Maybe people think, okay, now we have password. Okay, we hash password with MD5. Because he's broken, this password hash again with SHA-1. And now they use 3 algorithms, MD5, SHA-1, and SHA-2. And think, okay, we solved this problem. But it's not maybe a great right way. Okay, very important to know that wrong implementation or weak crypto functions could jeopardize the whole functionality of blockchain. Security, of course, but functionality. We don't have functional application on blockchain if we make some mistake, use a weak cryptography, or make some implementation error. Now I talk a little about IOTA. Do you heard about IOTA? Okay, IOTA now is ninth cryptocurrency by market cap. Here you can see market caps, and here is IOTA. It's a $5.3 billion market cap of IOTA, and IOTA is designed specifically for Internet of Things. It's a great, great protocol, and they use directed acyclic graph structure, where they it's the public ledger where they store information about transactions, and they use a Turner instruction. Because of that, they need to change something in crypto algorithms. They use They use SHA-3 Ketchak algorithm and modify some parts. When someone change crypto algorithms, which we use, it's a red flag for all crypto experts, for all people from faculty, from any industry who work, from math experts who work with cryptography, to test this algorithm on some maybe differential cryptanalysis when we talk about one-way functions. Nekla and her team from MIT found some vulnerabilities in this system. Okay, they said that it's serious vulnerability, but developers from IOTA said it's not serious vulnerability, and they have more general objections to the report. Okay, but Nayla and her team use well-known technique for breaking a hash function called differential cryptanalysis, and they can find collisions. When we find collisions in a one-way function, it's a problem. And if we know how to find these collisions, it's a great problem. They know how to use a computer with basic configuration and find collision, change some inputs data, and know that different inputs get the same outputs. Okay, they have the same signature for different inputs. What does it mean in maybe crypto world? Crypto world, I send you 1 Bitcoin. But if I know, I can change this information and put that you sent to me 1 Bitcoin and have the same hash of this block. It's a problem. Okay. It's a simple example. John Smith and Sandra D make the same hash value. And it's different informations, but we have same hash. Okay, it's not easy to find. And SHA-2, SHA-3 is resistance on this. But IOTA, it's a great protocol. Yes, developers from IOTA patch system and improve. Now they don't have this potential problem and bug. And but with this modification in IOTA, they make something new in IOTA. And this protocol, they said that this protocol resistance on quantum computer attack. It's a great thing. Okay, some notes from my side. Please don't roll your own crypto. Think about that when you develop something. Why? Okay, you can have great experts in the team, great math experts with 1, 2, or maybe 3 PhD from math, but you need to know that you don't have time for testing. Use only well-understand and well-tested crypto algorithms when build your system. Crypto algorithms like SHA-3, Ketchak, and Advanced Encryption Standard, for Advanced Encryption Standard, were selected as the winner of the competitions. And in these competitions, many crypto experts, many professors tested 1, 2, 4, 7 years. And they can find some bugs. These bugs, they change some of these, some other algorithms was not selected as a winner because he have some problems, and they have a time. When you develop, you don't have a time. Of course, you can change some parts of existing crypto algorithms, but you need to know where is the limitations. Thank you from my side. Please, Marko, tell more about smart contracts and some other.
Thanks. Okay, so a bit more about smart contracts. So let's say you do not want to implement your own blockchain solution from scratch. You would normally use an existing blockchain platform. So the second generation of the blockchain platforms like Ethereum, Neo, NEM, Quantum, Hyperledger, Fabric, the list goes on. They give you the ability to implement your custom business logic using smart contract. So what is smart contract? It's basically a piece of software residing on a blockchain, implementing some functionality, exposing some function API to users and to the other smart contracts to be able to utilize them. So I'll talk about Ethereum smart contracts. Ethereum is a, let's say, most used and most popular platform. And if you are a beginner blockchain developer, it's probably the easiest way in because there are a lot of materials out there on the internet. And it's a greater chance that you will find somebody to help you. Transactions, well, on the blockchain, like in real life, people send coins from one to another using transactions. But the same mechanism is used for the users to call smart contract API functions. Just in addition to the coin amount, users send the input function parameters as an extra data, as an extra payload. You have all probably heard about the last year top buzzword, initial coin offer. So what is, from a technical viewpoint, initial coin offer? It's just a smart contract. It could be more or less complex, with more or less features, but it's just a smart contract implementing some token or crypto asset and implementing a logic to handle it. So let's say going to the bottom of it, let's say a very simple smart contract would be just a token, sorry, initial coin offer, would be just a hash map of the user addresses and the amount of tokens they possess, the functions to handle initial distribution of the coin, and the function that enable token transfer between the users. So last year, let's say that was the greatest year for all the initial coin offers. Well, this, according to CryptoCompare, Ethereum has around 70% of the market share as a platform for the tokens, for the crypto tokens. And according to another report from Ernst & Young, last year, $370 million has been stolen from the initial, from the money that was raised by initial coin offers. So basically, that's like more than 10% hacker fee in this industry. So this is huge, to put it in simple words. And some independent researchers has shown that there are thousands of smart contracts out there having well-known and easily exploitable security flaws and bugs. And that and those smart contracts, they're handling like millions of dollars. So let's say smart contract reputation became a bit questionable. Why? Question is why. So while working on as a freelance Ethereum developer, I was able to witness some of the reasons. So first one is blockchain is very web-oriented. Normally, some ICO or more general smart contract decentralized application consists of front end, back end, having some usually registration, can know your customer logic, and the smart contract implementing a token on the blockchain. And more often than not, smart contract is treated as part of a web project, instead as a very important safety critical piece of code. So if you have your 100 lines of smart contract handling $1 million, you should really pay a proper attention to its security. So this is a new field. Initial Ethereum production release was like less than 3 years ago. So it's not surprised that there is a significant lack of experienced developers, or in general, blockchain developers. And that is becoming the very big problem, one of the biggest problem for the companies dealing with the blockchain. So let's say if you're bored with your current career, now is probably a good time to become a blockchain developer. I did it a year ago, and I'm very happy about it. Project stakeholders, sponsors, your customers, usually do not have a clue about the blockchain. So you have to explain them blockchain features, limitations. You have to tell them what they actually want and should do. Very often you have to explain them that blockchain could not fly to the moon. And consequently, during the project, requirements and design specification is changed a couple of times. So which is, of course, not very fortunate from the security point of view. Blockchain projects are very, very hype-driven as a whole field in general, so project deadlines are very unrealistic and not well thought of, and I dare to say frantic. So normally, in such a scenario, first thing you would sacrifice is security, additional security considerations. New field, so there is no consensus about the development, testing, and verification procedures, or to put it bluntly, they are not existent, especially testing and verification procedures. Tools are buggy. Under heavy development, they often break. You update your version of the tools, and it breaks something. Debugging support is very limited. It may work in your local environment, but not on the public or test Ethereum network. Actually, it reminds me very often, on my old days as a microcontroller developer, when I was debugging microcontroller with the LED diode. There is not yet integrated development environment. Also, nature of the smart contracts itself. They communicate with the outside world using message system like logs. But in the case that function throws an error, a log is reverted. Everything is reverted. So function call on a smart contract is atomic. So let's say if somebody calls you in the middle of the night saying, okay, our production smart contract function does not work, you really have to scratch your head to figure out what's going on. Also, there is a blockchain explorer, but the errors, you can see that function call has failed, but the error it gives you is very generic and non-informative. Nature of the blockchain itself, it's open, public, it's immutable. So everything you write is and publish, your project is totally open. So if you have made some critical error, some bug, it will first, somebody will be able to see it, and second, you will not be able to do anything about it, because once you deploy your smart contract, it's out there, and you cannot change it. There are, of course, strategies to overcome that, but it's advanced topic. So a couple of well-known attacks and smart contract hacks that were so the source of the problem was the error in the smart contract code itself. This is let's say granddaddy of all the Ethereum smart contract attacks. Happened 2 years ago, and it was so huge that today, thanks to this attack, we have two competing cryptocurrencies, Ethereum and Ethereum Classic. There was a hard fork as a consequence of this attack. Also, a couple of, let's say, last year problems with a lot of media coverage are parity multi-signature hack in June 2017. And this is a parity freeze hack. So this was allegedly accidental problem where one guy was able to become an owner of the wallet library in the blockchain, and he accidentally killed it. Basically, so all the people using this parity wallet, their assets became frozen. So there was like $150 million in Ethereum now frozen in the network, and nobody could do anything about it. So I would like to give you a taste of how the problems in the smart contract look like. These are a couple of well-known problems. So Solidity as a language is pretty similar to JavaScript. Now here, okay, this is a common function in the smart contract. So you want to enable your users to withdraw their Ethereum from the smart contract. And here you get the user amount, you send that amount to the user address, and you update the user balance. But target of this transaction could be another smart contract. Their user on Ethereum, user and smart contract addresses are the same. They're indistinguishable. So the other smart contract could have an event handler calling back the same function again. And basically, with the recursion, it could drain out all the money from your smart contract. And this problem was the source of the first DAO hack that happened 2 years ago. You probably all know about the underflow and overflow. In Solidity, there's an unfortunate fact that it silently ignores the overflow and underflow. So, okay, it uses the 256-bit word, so there's not a big chance that you will overflow unless you're doing with a real lot of digits. But for example, in this case, if the part is bigger than the total, this function would silently return some really, really huge number. So this kind of problems, you really have to pay attention on them. And this is a typical, a simple auction contract. It's also a very common use case on the Ethereum, where the user sends bits together with the amount that is then locked in the smart contract. So if your bid is bigger than the previous highest bidder, the money is returned, the Ethereum actually is returned to the previous highest bidder. But like in the first case, if the previous highest bidder is another smart contract, and it intentionally reverts this transaction, then the whole bid function call would be reverted. And basically, you here have a denial of service attack. Nobody else would be able to become a new highest bidder. So a couple of, let's say, tips and lessons I have learned while working on the Ethereum projects are, well, as the first, a very important one, you must not develop your smart contract from scratch unless you have a very extraordinary use case, which is not likely. So use community, well-tested and well-audited smart contracts. There is a most popular smart contract library is Open Zeppelin, and you can usually inheriting from couple of smart contracts. There's a multiple inheritance in the Solidity, like in C++. You can have 80 or 90% of the functionality from start. You just fill the pieces that are missing, that are very specific for your use case. Also, Truffle is the most popular Ethereum development environment. There are others, of course, but this is the let's say, most used. And it gives you the ability to create a template project, to build it, compile it, test it, and deploy it in the network. So even if you are a beginner blockchain smart contract developer on Ethereum, you can easily have your new token deployed in the production Ethereum network in like a day or two. Always keep smart contracts as simple as possible. So the less code you have, there's less chance that you'll have some bug, and then somebody would steal your Ether or money. And also there's another important reason for this. Currently, Ethereum does not scale well. So functions are very expensive on a production network. They may become very expensive. You do not want your users to pay a couple of dollars for every function call. Always put most of the logic off-chain, at least now, in this moment. You should put most of the logic off-chain, and only important pieces that must be decentralized, they should reside in the smart contract. Well, needless to say, testing is important, but I have seen some projects, smart contracts, without a single unit test. So you really have to pay proper attention to writing unit tests, let's say having hundreds of them for one smart contract. And also, normally I have tested my smart contracts like integration, especially integration with the rest of the decentralized application. I have deployed them like 20, 30, 50 times on the test on or production network. Always have the worst case in your mind. So what would happen if the judgment day would come for your project? You need to enable users to, in case of the ICO, for example, you need to give ability to users to withdraw their funds, so that you can pause the contract and for users to withdraw their funds. Or you should have some strategy about, let's say, if there's a critical bug in your smart contract, that you could migrate the whole functionality or your use case, your business use case, to another smart contract with a fix. So always, good advice is always think the worst case. It may actually happen. Front end and back end of your application normally communicate with the smart contract using Ethereum nodes. Most popular are get or parity. And very often, node would not work very well. They became buggy or it is not synchronized. So always have the redundant infrastructure. Like have 5 different nodes on different computers sending events to your database, let's say off-chain database. In the first case, if your nodes are not synchronized, with the rest of the network, your state of the front end would be wrong. So you wouldn't know what's the current status of your smart contract. Well, there are not so many security auditors out there, especially not experienced one. And they may be very expensive, but you should really always have your smart contract audited, externally audited, before going to production. Okay, I think we have time, Luka. Luka would show us a bit more about it's a very interesting story about the anonymity of the Bitcoin transactions.
Just some websites where I want to show you more about blocks, about information in the block, about transactions. When we think about confidentiality, integrity, availability, and anonymity, we could see that we have integrity when we use one-way function. When we use asymmetric cryptography, what do you think? What we have from this? Confidentiality, integrity, availability, or anonymity? What do you think? Confidentiality? Okay, we have. Integrity? Okay, yes, we have. But anonymity, we don't have. You need to know that when we work on some blockchain project, because many people think that this address, where are some random numbers, are not anonymity informations. These informations we have because we use private and public key, and in Bitcoin we can find many different addresses for one account. Here, on this site, blockchain.info or some other, you can find more information of each block. Here, do you see it? It's okay. Here, you can see the number of block. Okay, I don't update this site from yesterday because I don't use internet now. But I can show you one block which I find. With this block was formed on April 27th. In this block, we can see many other informations like maybe transactions, fees, like a hash value of this block, hash value of the previous block, difficulty, and many other information, because we can scroll down and show all transactions, all addresses, and we can see that someone from this address move money on this address. In blockchain, you have more than one address. But when you want to pay, and this protocol sum all your coins and move part, how many you want to pay on a new address. It's this address, and the rest of your balance move on a new address. Okay, I find one interesting address with 423 Bitcoins. Now it's around $3.5 million. If you're a hacker or someone who wants to steal money from other person, now we don't know who believe this address, but you can find on the internet, maybe in a post, oh, I bought on Amazon, I first who bought on Amazon in Bitcoin, or maybe, okay, please donate me on this website for animal protection or something others. And with this information, we can find more in the blocks and know how much Bitcoins these persons have. If you track on all of these addresses, you can click and you can see more about these addresses. You can, if we click on this address, we can find that from this address he moved money on your address, and we can track all of these tabs, track this money, And at the end, we can find that he moved all money on this address on May 15th. And now he have 470 bitcoins. If you know the name of this person, you know his balance. You know if maybe he earn more bitcoins on spend or all others in the future. Thank you. It's just a few information about anonymity.
Thank you, Luka. Thank you, Marko. We actually have 3 short little questions, but actually one question that ties in really well is, do you think Solidity, Marko, is probably the best language to
Okay,
use?
so
Is it the best fit for smart contracts?
it depends. What do you want to do? For example, if you're a typical corporation, you can have a private blockchain network, but it may not be the best solution. Maybe you should use a Hyperledger or EOS. They have a more corporate-like features.
Okay.
It depends really on the use case.
Question for you, Luka.
Second, okay.
Was the BitGrail cryptocurrency exchange, I think it's an Italian exchange, was this fail a hack, or was it a failure of implementing the proper security?
The 95% of all hack activities on the internet based on social engineering, all, not just with blockchain, with the networks, with the bank account, based on social engineering. But if we eliminate this part because it's great, second, third, it's a problem with implementation. Problem with implementation with the databases, with some maybe settings in a router, maybe with the code, with smart contracts, or with the implementation. Twitter said that some passwords we don't hash. We have some problem, some passwords we save like open text. How it's happened? How you can save some passwords in plain text? That means that some people in the Twitter, administrators or maybe others, know your password and can use your account. That's easy. Okay, and I want to say more about one question about how to implement it. I read one question, how to implement it, where we need to start if we want to implement it, this in our company. In my bank, I talk with the CEO, with IT directors about blockchain. We think about blockchain. We not think just about blockchain. We think about artificial intelligence, machine learning, and try to use it. We can't move our business from situations where we now in blockchain or in artificial intelligence. But we need to think about that. Use some simple projects because we need to be similar with this technology and to know how it's works. Tomorrow, we do it for the future because in the future, when we use more blockchain, maybe in the banking sector, maybe in a core system, because every part of your core system in each company, you can move in a blockchain. If you share some information with governance or with some clients, you can move it in blockchain. And with the rights, they can use this and see this information.
Thank you. The one last question before we take our break. What do you think about a new Viper language for Ethereum smart contracts, Marko?
I haven't worked at it, so I cannot comment. I'm looking forward to seeing new languages, and that will be an interesting field. So basically, the Ethereum virtual machine is very similar to Java virtual machine. So you can have any language compiled to that. So I'm looking forward to learn more about it.
Marko, Luka, thank you very much.
Thank you very much.
Yeah.